All right, today we're talking about absolute values special cases. That is, when it doesn't really work out as normal. And what happens is an absolute value makes pretty much everything positive. So if you put a number into an absolute value bar, then the answer that comes out will be a positive number. Therefore, you cannot have an equation where an absolute value gives you a negative answer. If this is the case, if you have the absolute value of something that is supposed to be equal to a negative number, there is no solution to that equation. And this happens a lot. Well, not a lot, but I mean, it does happen from time to time. For instance, here, this is a very simple absolute value equation. It's a very common mistake that people make, and they just sort of, get too busy and not paying attention to what's going on around them, and they just go for it. And so let's just do that and see if it works. P minus 8 is equal to negative 17, and P minus 8 is equal to a positive 17, because we again have to change the sign to figure out what number will come out. So we'll solve this, and it's going to work out just fine. We'll add 8 to both sides, and P is equal to negative 9. And then we will add 8 to both sides on the other one as well, and P is going to be equal to 25. And these are my two solutions. And you say, oh yeah, sweet, all right, that was easy, but you're too lazy to check your work. And if you check your work, I think it should be fairly obvious. Let's go ahead and plug this in here. Well, absolute value, negative 9 minus 8, close absolute value, is supposed to be equal to a negative 17. But when I calculate this, negative 9 minus 8 is negative 17, but it's still in the absolute value bars. So I end up with an expression that says 17 is equal to a negative 17, and this is not true. And since that is not true, that means that this answer didn't actually work. And we can see the same thing happen if I plug in 25 in for P, and we write that down. Absolute value of 25 minus 8 is close absolute value is supposed to be equal to a negative 17. And that's all well and good until you start calculating. Absolute value of 17 is equal to a negative 17, and again we're left with a statement that says 17 is equal to a negative 17, so that does not work either. And therefore this equation has no solution. Now that is a very simple rule to just take and run with. If it says absolute value is equal to a negative, then there's no solution, you move on. You got to be careful, though. Whenever you're doing some problems like this, there is an occasional time, let's see if we can find one, where it's not always the case. So we look at number 18 right here. Again, it's not a very difficult looking question, but you say, oh my God, look, it says equals a negative 47. And that's not allowed. Absolute values can't equal to a negative 47. So no solution, and you'd be done with it. But you would actually get the answer wrong in this case. That is not true. Let's just see what happens. Remember, absolute values, you want to take care of everything outside of the absolute value bars before you actually go. So we'll subtract 9 from both sides, and that's easy enough. Negative 56 is equal to negative 4, absolute value of negative 7x equals. Now we want to get rid of the negative 4, and so we'll divide both sides by negative 4. And lo and behold, what is going to happen when I divide by negative 4? Absolute value of negative 7x is equal to. And then 56 divided by 4 is 14. But now it's a positive 14. It was a negative, but it became positive in the process of getting the absolute value alone. Now, this is where we would break it up into two equations, and they're very simple equations. Negative 7x is equal to 14, and negative 7x is equal to negative 14. We'll divide, and x will be equal to negative 2, and x will be equal to a positive 2. And these are my two solutions that I have received. Now the question is, do those solutions actually work if I were to check them? So we're going to take the negative 2 and we're going to plug it in. Negative 4, absolute value of negative 7 times negative 2, close absolute value, plus 9 is supposed to be equal to a negative 47. And we'll calculate this out. I always start by calculating the inside of the absolute values, just like it is a set of parentheses. So that would be a positive 14 in there, plus 9 is equal to negative 47. We'll then calculate what the absolute value of 14 is, and that is simply, well, 14. Negative 4 times 14 plus 9 is equal to negative 47. And then we get negative 4 times 14 is negative 56 plus 9 is equal to negative 47. And yes, negative 47 is indeed equal to a negative 47. That worked. The same process can be applied to the positive 2, and you will see that that one works as well. So don't jump the gun. Don't go too fast, or else you'll end up suffering for it. It says equal to a negative 47, but in the process of getting the absolute value alone, it changed back to a positive number. So it was a perfectly fine equation. Now we're going to move on to absolute value inequalities. Absolute value inequalities work very similarly to absolute value equations. They just have a number line that we have to deal with. So we're going to go ahead and do this one just like what we've been doing, and would say r plus 2 is greater than a negative 8. R plus 2 is less than a positive 8. Remember, you change the sign when you change the sign. So this is the equations we have. We have to determine, is this an and or an or graph? And you say, okay, well that's a greater than symbol, so that must be an or, greater. We will now need to solve both of these very simple equations and graph them. We'll subtract 2 from both sides and get negative 10. R is greater than negative 10. And then we'll subtract 2 from both sides over here, and we get r is less than 6. And these are my two solutions. Now what's going to happen when we graph them? Well, that's an interesting thing. First of all, I'm going to graph this r is less than 6. That is an open circle, and it is going to go to the left. And for some reason or another, this number line doesn't go far enough to deal with the r is greater than negative 10. So I'm going to just, make some more lines and put the dot right here. That is an open circle, and it's going to go to the right. And you say, okay, well that means it is the area in between this. But wait, it's not just the area that is in between this, because this is an OR graph. And an OR graph means that, well, it's got to go everywhere, that any arrow is. And so it is going to keep going this way because the red arrow goes that way, and it's going to keep going left because the green arrow goes left. And in fact, it covers the entire number line. Everything gets covered by something, either the red or the green. So this is an example of all real numbers. This is a special case absolute value inequality. And there are two options for that. So let's go ahead and jump up to the notes on number 26 about absolute value inequalities. And the special cases, again, happen to whenever we have negative signs. An absolute value, again, is always positive. All right, well, this is not technically true. It's at least always non-negative. It could be 0. It is always positive for the most part. Therefore, if it is less than a negative, all right, therefore, if an absolute value is less than a negative, a positive is never going to be less than a negative. So you have something like this. Absolute value of something is less than a negative 2. Well, this guy is going to be a positive number. I don't care what positive number it is, but it's going to be a positive. And a positive less than a negative doesn't make sense. That can't happen. So this is an example of no solution whenever we talk about absolute value inequalities. But since it is a positive number, positive numbers are always greater than a negative number. So that's like what we had in the last example. We have the absolute value of something is greater than a negative number. Well, this is a positive again. A positive number is always greater than a negative number. There is no value that you can put inside the absolute value bars that once I calculate it, it will be a positive, and there is no value that will make it somehow magically smaller than a negative. So this is an example of all real numbers. Because no matter what you put in, no matter what you put into the absolute value bars, it will always be bigger than a negative. And those are the special cases. Let's take another example just for, posterity's sake. So we'll go ahead and let's do this guy right here. I'm going to go ahead and solve it like I didn't know that this is going to be a special case or something. So if I'm not paying attention to the fact that that's a negative 64, then, well, it it might make me do more work. So let's go ahead and try it. First thing you should always do is get the absolute value alone. Bam, it's alone. I divide it by 4. Absolute value of 9v minus 7 less than, we don't change the sign there. And 64 divided by 4 is, what, 16? Negative 16. So this is my equation. And if I haven't realized yet that that negative 16 is going to give me a special case, well, we could go ahead and solve this. 9v minus 7 is less than negative 16, and 9v minus 7 is greater than a positive 16. This is an and because that's a less than sign, less than. We want to go ahead and graph or solve this, so we'll go ahead and add 7 to both sides, and 9v is less than negative 9. Therefore, v is less than negative 1. And that's a perfectly good response. And we'll go ahead and add 7 to both sides. 9v is greater than. Now 16 plus 7 is 24. We'll go ahead and divide that by 9. And v will be greater than. And 24 divided by 9, you say, well, what goes into 24 and 9? 3 does. So that'll be 8/3. Now 8/3 is approximately 2.6 repeating. Okay, it is exactly 2.6 repeating. So anyway, what we want to do is we want to graph these on the number line and see what happens. So we're going to do the blue one, that is less than negative 1, open circle going to the left. And then we'll do the red one, which is greater than 2.6. So that is open circle going to the right. This looks like an OR graph, but we already said this is an AND graph. An AND graph means that the overlap very much matters. And so that thing right there, well, there is no overlap. And since there is no overlap, this would be an example of no solution. Now, it is very common that people will just do it and graph it and be done and not even consider the fact that this is an AND graph. So you want to make sure that you're thinking about every step as you're going through this. Because if you realize at this phase right here that an absolute value cannot be less than a negative because absolute value is positive, you could have written no solution down with saving you all the rest of this work. So just make sure you think up front and you can save yourself a lot of effort.